The views and opinions in the following program remain those of the producer or sponsor, and not those of Medford Community Cablevision, its staff, management, board of directors, or other affiliates.
Hi, welcome to Mathman. My name is DeLucia, and today's topic is going to be the metric system and some of the comparisons between the English system that we use in the United States and the metric system which most of the other countries of the world use. But before we start, behind me is a number, and it's a rather large number. If you know that number and you follow politics, you know that number is $15 trillion. It's the amount of debt that the United States has right now, soon to go up, I'm sure, to more. And if that number doesn't scare you, you should be scared for your children or your children's children, because that's money that has to be paid back. But that number is so large, it's so scary, and people don't know how to put it into context. Let me try to put it a little bit into context before we start. If you made $1,000 a week, which is $200 a day, 8 hours a day, which is basically $25 an hour, you make $52,000. But we'll say $50,000. That $50,000 is more than the average household in America makes. Look at the two of those numbers in comparison. That $15 trillion is what's going to have to be paid. It's going to have to be paid back, and it will grow because interest is going to be owed on it. Now, how do I know it's $15 trillion? Well, if you've seen some of the other programs we started with numbers, it's real simple. Ones, tens, hundreds, and it gets repeated. So this is the ones group, the thousands group, so 1,000, 10,000, 100,000. Then the millions, 1 million, 10 millions, 100 millions. Then the billions, 1 billion, 10 billions, 100 billions. And then we get to the trillions. And God, I hope we don't get beyond that. But it needs to be paid back. And that's one of the things that's holding back the economy, because we just can't pay back that amount of money quickly. It's going to be decades before it gets paid back. All right, the metric system. It's what most of the world uses for measurement for volume, for length, for weight. And we're going to start with some of the things that we know and make a comparison. And just like learning a language, when you start to learn something, it becomes a bit more confusing. And the simplest thing to do with the metric system is to compare it to money. Now, everyone understands how money works, and the metric system is based on the same principle of base 10. So with money, we have $1. $1, no tens, no hundreds, no pennies. We have a penny. We have 5 pennies, or 5 hundredths. We have 10 cents. We have 25 cents. We have 50 cents. And those are common units that we have for coinage in our country. It's very easy for us to work with this because it's based on the base 10. Imagine if it was just like, imagine if it was just like the English system that we have a measurement and based on fractions. We'd be doing things with fractions like this: 1 100th, 1 20th, 1 10th, 1 4th, and 1 half. Imagine trying to add those numbers up when you went to Dunkin' Donuts and you gave the girl some change and tried to get something back. So the metric system is based on the base 10, and it's easier to use. But like I said, in a foreign language, we get frightened a little bit. We get a little concerned about how do we function with something that we don't know. So let's start and see if we can make it a little bit simpler. And I think the simplest way to start is to start with our English system, so we get a small comparison. When we use measurements, length, the base that we use is feet. Okay? We have feet, and the smallest part is inches, which makes up some of the feet. Then we have yards, and then we have miles. And they're all related. But they're not related in a systematic way that you can figure out. They're related by ways you have to memorize. For example, we have feet, and let's say that's our base, and we're going to just say that's 1. Now, how many inches are there in a foot? Well, there are 12 inches. How many feet are there in a yard? Well, there are 3 feet in a yard. And how many feet are there in a mile? There are 5,280. So you have to memorize all those things, and to make a calculation and changing it it's not the same as making changes or calculations when we use our coinage, when we use our money. It becomes much more confusing. Now, there are some wives' tales about how these measurements actually came to being. One of them is that if you take the distance between these two knuckles, that's an inch. And the other one is if you take the distance between your nose and the end of your finger, some ancient king or some English king, that was a yard. And they took that and either broke it up into feet or they broke it up into inches. I don't know, but all I know is to work with this is much more confusing than to work with simple base 10, moving a decimal point back and forth. Right? And you've heard some of these other words, but we don't use them now. They were used much more in colonial times. But there is something called a rod. All right? And this is in between, let's see, feet and yards. Well, how about here? A rod. Now, a rod is 16.5 feet. Now, if you go Route 16 in New Hampshire, there's a road called 10 Rod Road, and I'm sure for some distant past, I mean, it was 10 rods, and they measured it that way. And let's see, there is one other one that I wanted to do. Oh, yeah, this one for you people who like to gamble, a furlong. If you like the horses or you like the ponies, a furlong is 1/8 of a mile. It's furlong. Now, look at all the inconsistency, or the difficulty would be to changing one of these to the other one. If we wanted to know if there were 42 yards and we wanted to change them to inches, what would you do? Well, you'd have to find out how many inches there were in 1 yard, which is 36, and then you make your calculation, and it becomes a large number. It's not a simple way because with feet you use a different number, and if you want to change them into miles, it's a different number. And the metric system eliminates that confusion if you can just think of it as a new way of doing things and make it a simpler way. All right, let's start in with some of the metric system then. Let's take, what do I have? I had weights. Not sure I want weights. Let's take measurement with lengths here. All right? The metric system is based, we'll say the central thing is a meter. Now, how long is a meter? Comparatively, it's a little more than 39 inches long, a little bit more than a yard. And people think of that in their mind, and we always sort of translate things. If, for example, if you're learning a language and you're learning French, you try to get the English word and translate it. And I was never good at languages, but the people that are good say, you don't think in your language and translate. You think immediately in the language you're starting to work with. So for comparison purposes, I guess we could say a meter is comparable to a yard, but we should start thinking in just lengths of a meter. Now, you know what a meter is, and you've also seen the signs, or you know what a kilometer is. Now, the prefixes in the metric system are pretty similar all the time. They go from weights to liquid measurement. A kilo, or kilo, is 1,000. So this is a meter, and this is basically 1,000 meters. 1 meter, 1,000 meters. Once again, you're working with the base 10. Now, you've all seen the word centimeter. Now, centi, or cent, if you think of it, is 100. A centimeter is 1/100th of a meter. So 100 centimeters equal a meter, just like 100 pennies equal $1. And they have something smaller called a millimeter. Millimeter. And this is 1,000 of those make up a meter. Now, we have something in our money that deals with a thousandth of a dollar, but we just don't use it. In fact, I predict in the not-too-distant future they're going to get rid of pennies, too, because they cost too much to make. But you have 1,000 of these make up a meter, 100 of these make up a meter, 1 of these makes up a meter, and 1,000 meters make up this. Now, there are some other ones in between, too. They're not used that much, but they're in there. They have decimeter, D-E-C-I, meter, and it's 10 of those equal a meter. So it's 10 centimeters equal a decimeter, and 10 of those equal a meter. And they have down here a decameter, and it's 100 meters, deco, D-E-C-O, equals 100 meters equal a decameter, 10 decameters equal a kilometer. Now, I know it's confusing and you hear all these things, but the main things are meter, centimeter, millimeter, and kilometer. Those are the things that make up most of the metric system when we measure it. If you go on the Main Turnpike, you'll see close to Portland, Maine, they say an exit is 1 mile away or 1.6 kilometers away. So a kilometer is smaller than a mile, and they use those up in Canada. Now, the interesting thing is our system is called the English system, but the people in Canada don't use the English system, and they're closely tied to England. They use the metric system like most of the world. In the 70s, there was a big push to go to the metric system. I think President Jimmy Carter was pushing it, probably the only thing he ever did that was worthwhile, political statement. But it was stopped, and I think it was stopped by two groups of people. One, the population of America was just so frightened of the metric system, they didn't want to do it. And the other thing was, and I don't know this for a fact, but I would assume that the tool makers who sell 2 sets of tools to everybody who works on cars, who is a carpenter, who uses the English system for tools, for wrenches, and they have to buy 2 sets. They have to buy an English set, and they have to buy a metric set. Now, I have 2 old sports cars. One is English, one is metric, and I have 2 sets of tools. It certainly would be cheaper to have 1 set of tools, but we have 2 sets of tools, and I think that's one of the reasons it stopped it. Commerce didn't want to do it. Okay, how about weight? Now, the metric system has length, volume, weight, liquid measurement, and we have weight too. Take a second to think about what we use for weight. What is our standard of weight when we're weighing anything? That's right, it's the pounds. We call them lbs, the pounds. Now, a pound is made up of ounces. How many ounces are in a pound? Right? Ounces are in a pound get mixed up with ounces in a quart. One's liquid measurement, one is weight. Just a quick story on this. When I was teaching, I had a ice cream stand with a friend of mine. I certainly hope he's not listening. But we started an ice cream stand, and we were losing money. And the reason we were losing money is because when he figured out, because he worked for Friendly's for a while, when he figured out the amount of ice cream that should go into an ice cream cone, he was using liquid measurement of 32 ounces in a pound rather than 16 ounces in a pound. So when he was figuring it was costing us half the money to put money in the ice cream when it actually was costing us twice as much as he thought. So we were losing money with every single ice cream cone, and we finally realized that, and it did cause a bit of a problem. But we have pounds. What makes up pounds? Ounces. How many ounces are in a pound? 16 by weight. Now, believe it or not, there are measurements of weight that are smaller than ounces, called drams, and chemists use these a lot. And I think they were used 100 years ago or so more. And they have grams, which is an English measurement that goes beyond the drams. But just so you know, there are, there are 512 drams in a pound. So that's a pretty small unit of measurement, and people don't use that anymore. And we also have, after pounds, we have tons. And what is a ton? An English ton is 2,000 pounds, makes up ton. And there's something actually in between that you don't hear much, but it's called hundredth weights. And a hundredth weights basically is a hundredth. You know, it takes 20 hundredweights make up a ton, because if you have 21 hundredths, that's 2,000 pounds. Okay? All right. Now, what do we have in the metric system? For the metric system, we use gram. A gram. It's a unit of measurement. It's a small one, much less than an ounce, but a gram. And we also use something, a kilogram. And if you were paying attention when we did the length measurement, then you know a kilo is 1,000. So we have 1 gram, and this is 1,000 grams, and it makes up a kilogram. And they also have what they call a metric ton, which is basically 1,000 kilograms. Once again, everything is based upon a multiple of the thing before it. And just so for comparison purposes, an English ton is 2,000 pounds. A metric ton is approximately 2,200 pounds. So a kilometer is less, but a metric ton is more. Now, one of the things that we hear all the time is centigrade and Fahrenheit. Now, there is a formula to convert that, and we see these temperatures all the time. And I thought it might be interesting just to put the formula on the board, because when we go by, some banks usually have them. They'll tell you what the temperature is. Sometimes they put it in centigrade. And I've always wondered, 17 degrees centigrade, is that hot? Is it cold? I don't know because we're not used to it. Okay? So let's take a formula and transfer our Fahrenheit to centigrade. First, let me give you the formula. It's 0 degree, the Fahrenheit minus 32 times 0.56 equals the centigrade. So the degrees Fahrenheit minus 32 times 0.56 equals centigrade. All right? I have a couple of examples here that should be simple to use. Let's say it's 100 degrees. All right? Well, we plug it in here. Now, for those of you, this is a problem solving. This is basic algebra. And this is what we used to teach in the 7th grade to get started with pre-algebra. So it's a system of how to do things. Now, what do we do first? Do we multiply this? Do we subtract? Well, you always do what's in the parentheses first when it comes to solving equations. So 100 minus 32, okay, we get 68. We add times 0.56, and that's going to equal the amount of degrees that we have in centigrade, and that is 38 degrees centigrade. Now, it may seem like it's cold, but if you're used to centigrade, you understand that it really isn't. Well, it's usually not 100 degrees, so let me just leave the 38 up there. That's for 100, and let's get something that happens around here a lot. 100 degrees Fahrenheit. That's 38 degrees centigrade. Let's say it's 72 degrees Fahrenheit. All right, we have 72 degrees Fahrenheit minus a constant of 32 times 0.56 equals degrees centigrade. Okay? So we have 72 minus 32, which is 40, times 0.56 equals degrees centigrade. 40 times 0.56 is 22 equals degrees centigrade. So when it's 72 degrees out, and you hear them say it's 72 degrees, it's 22 degrees Fahrenheit. Okay. How about going the other way? Because people get it one way, and then they get confused going the other way. And it's the formula that's important, because you just plug it into the formula. And after a while, you've basically memorized what the difference is in degrees. Okay, so now we're going to go to centigrade to Fahrenheit. So here's the formula. 0 degrees centigrade times 1.8, which is a constant, and it's figured out mathematically. You don't need to know how it was, but it does work. And then you add 32, and you get the degrees Fahrenheit. So, an example. The one we had, let's take 22 degrees times 1.8. Don't forget, this is degrees centigrade, plus 32 equals degrees Fahrenheit. We got 22 times 1.8. 39.6 plus 32 is going to equal 71.6 degrees Fahrenheit. Now notice it's not 72. That's the number that it was, but it's close enough. And that brings up the concept of measurement and what is exactly. And every time we measure something, we're not measuring exactly. When we count items, it's exact. Let me give you an example. This is one marker. It's not 1.2 markers. It's one marker. And it's always one marker. Yet if I put this on a ruler and I measured it, let's say it was 4 inches exactly. It's 4 inches. But is it 4.00001 inch? Or is it 4.01 inches? I doubt if it's exactly 4 inches down to the billionth place. There's got to be something off somewhere. So when we measure things, we're really getting to the point where it's not exact 100%, but it's so close it really doesn't matter. For example, if you hit the lottery and you won $100 million, or if you won $100,000,001, what would you tell people? Oh, I won $100,000,001? You say, I won $100 million. Because that $1 is virtually meaningless to the overall concept of what you won. It's the same thing with measurement. Whether it be weight, you get on the scale, and you see 150 pounds. Well, maybe it's a tiny bit more or a tiny bit less, but I doubt if you're 150 pounds exactly down 10 decimal places. You might be 150 and then 1/1000th of the next pound. So technically, you're not really 150, but in the world where it doesn't really matter, we say 150 pounds. Okay? And just one last one, the one that deals with when you go to 100 degrees. Instead of putting 22, if we put 100, no, I'm sorry, that was 38. I'm going the other way. 38 degrees centigrade. We multiply it out. We're going to get, seems like my finger's a better eraser than the eraser we have, 68.4, and it comes out to be 100.4 degrees Fahrenheit. Once again, it's close enough. I think if it's 100 degrees, it's not going to matter that it's 100.4. However, if you have a fever, that makes a difference because what we're measuring is something so small, it really doesn't matter that much. The metric system is just so much easier to use than our system. What about liquid measurement? Here's a quart of oil, right? Shell formula oil, and it says U.S. quart, 1 quart. However, can you see this up close? Just that? Back up? See right down bottom here. It says 0.946 liters. 0.946 liters means it's not quite 1 liter. So what does that mean? Is a liter bigger or is a liter smaller than a quart? Well, a liter is bigger than a quart. And it's slightly bigger than a quart. Not much, but it's a little bit bigger than a quart. What do we use for liquid measurements? Well, we use quarts, usually as a standard. Quarts. We have gallons. And we have pints. And we have cups. And we have spoonfuls, teaspoonfuls, and all that stuff if you're a cook or a chef. But the one that's standard usually is a quart. We have 1 quart. Now, how many quarts are in a gallon? Once again, unlike the metric system, not based on 10, it's just an arbitrary number. Someone had to decide they wanted 4 quarts and we want to put them in a gallon. Right? So it's 4. What about pints? How many pints are there in a quart? Well, there are 2 pints in a quart. Someone had to decide, let's cut a quart in half, we'll call it a pint. And what about cups? There are 4 cups in a quart. And what about ounces? There are 32 liquid ounces in a quart. So look at all the conversions you have to do in your mind. Now, you do this so quickly, most of you, because you're just used to it. If it was a metric system, it'd even be simpler. So how many ounces are there in a cup? Well, there are 8 ounces, because 4 times 8 is going to equal 32, which equals 1 quart. How many ounces are there in a pint? Well, there's 16, because 16 times 2, once again, equals 32, which equals a quart. And a gallon? How many quarts are there in a gallon? Well, there are 32. In a half gallon, there's 2, that's 64. In a full gallon, there's 128. I remember when there was Bradley's down at the Meadow Glen Mall, they had a sale. And I think it was on whisk detergent, but they had 2 half gallons. And they had half gallons, and they were selling the half gallons, and the half gallons were on sale. 1 half gallon bottle, they were on sale for $3.99. But each quart they were selling, 1 quart, regular price was $1.69. And I stood there for a while, and just because I was curious, more people bought the half gallons than a quart. If you bought 2 quarts, you would pay less than you paid for the gallon. And I think that's because most people, in their mind, see the word sale, and they jump at it right away. But I don't think they could do the math. And it's really simple to do the math. I mean, if you round this up to $2, and say 2 quarts would be $4, and I know it's going to be a lot less than that, so you're foolish to buy the half gallon rather than the quart, the 2 quarts rather. Let's see. Oh, if you have any questions or a topic you want to see, especially if you have some children in school and you want to do some things that are more advanced, please call the station, let the station manager know, and we'll cover the topic. We're setting up a website where you can ask questions, and we're probably going to have some problems set up and some answers on another page, so if you're interested in doing some puzzles, might help you up with your schoolwork or just general stuff. And if you look at math as a way of having some fun or just a puzzle, I mean, do you do the math puzzles in the Globe or the Herald, the Sudoku puzzles or the other puzzles they have? It keeps you sharp, it keeps you alert, especially if you're an older person. They've proven that using your brain and exercising it keeps Alzheimer's at bay. It's something that is something we need to do, because there's nothing worse than being physically fit but not remembering what you did the day before. Right? I got some of this information on the web. If you go into the web and you go to Google and you type in metric system, you'll find they have sheets and sheets of all these things, and they make it very simple, and they give explanations for things, and you can get an awful lot of information. Google was never available when I was a youngster. I was in school. I think it's one of the best things out there. It also helps ruin some stuff, because I think it's helping to destroy the feeling of going to the library and spending time at the library. And we've got a great library in Medford, and I know the librarians are good. I used to use it all the time. Thanks for listening. An interesting thing, a metric ton. How about this? A liter of water weighs 1 kilogram. So 1 cubic meter, 1,000 liters of water weighs 1,000 kilograms, or 1 metric ton. Maybe that's the way they figured it out, I'm not sure. But they do have a platinum bar that's 1 kilogram. Once again, thanks for listening. I'm Ron DeLucia. You've been watching Mathman. We'll see you again.